All right, so we're going to take a crack at this problem now. This one's a bit different because we've got an exponential term here, and we have been looking at resonance problems. I'm also going to make some initial conditions, just so we've got a bit of variety. We've actually got to plug in and find some constants. Okay, so we proceed as normal. We solve the associated homogeneous problem. YH double prime plus Y prime H minus 6YH equals nothing. We sub e to the lambda t. So we get lambda squared plus lambda minus 6 equals nothing. That's a quadratic. It's actually one that factors quite nicely. So I rarely do them by factorization, but this one has nice factors. So we've got now two real eigenvalues, and our homogeneous problem has general solution this. Now, if we go and look at our driving term, whilst it's no longer sines and cosines that we've been looking at, e to the 2t solves the homogeneous problem. This is a resonance case, just like every other resonance case that we've come across, right? When we use our undetermined coefficients, we're not going to be able to simply guess an exponential right-hand side because that solves the homogeneous problem. We have to revise our guess for the particular part. So our hypothesis is still y is a sum of YH and Y particular, where Y particular now is equal to T times some constant C naught e to the 2t, right? That's what we need to guess for this right-hand side and the resonance case, right? This T comes from resonance, this comes from matching the exponential. All right, so we know that when we substitute this guess into our ODE, the homogeneous part's going to go away, and we're just going to be left with the ODE for the particular part. So I'm just going to start by writing down the ODE for the particular part only. We don't need to worry about what our homogeneous part's doing because we know that it's going away. That's our ODE for a particular part. So we need y prime, or yp prime and yp double prime to substitute in. So let's get cracking through this derivative. Yp prime, it's a product rule. Differentiate the first one, leave the second one alone. Differentiate the second one, leave the first one alone. Yp double prime. That's no longer a product rule, it's just a straight up derivative. This is a product rule. We got to take care of it by the product rule again. It's like t times e to the t again. And if you're clever, you'll recognize the pattern that we're going to, it's just like take this away, plug this in. It's kind of recursive, but I'm just going to do it slowly. Differentiate the first one, leave the second one alone. Differentiate the second one, leave the first one alone. Okay, there's obviously some simplifications here, but I'll wait until I stick it in the ODE completely to make those simplifications. So let's just plug it in. So there's going to be 5 of these by the time I'm finished. Actually, I'll just plug it in, and then I'll collect all the terms rather than chasing them all down now. Okay. This one, this one, this one, they all match. This one, and this one all match. 2 plus 2 is 4, plus 1 is 5. 4 plus 2 is 6, minus 6 is 0. So once again, this t term disappears, which is great news because we haven't got a t e to the t term here to match with on the right-hand side. But very clearly, c naught is equal to 1/5. That's great. We're done. We've got our y particular now is 1/5 t e to the 2t. We know our y homogeneous, so we can write down y overall. Now I had some initial conditions, so I better plug them in now. So I'm going to stick in my first condition, y naught equals 0. 0 equals a plus b plus nothing, right? Because we've got a 0 out there. So a plus b equals 0. That tells us that a equals minus b. That's not a great deal of help to us right now, but it's a relation that we'll have to satisfy later. Now we need y prime of naught, right? So we're going to have to differentiate this. Y prime equals 2a e to the 2t minus 3b e to the 3t minus 3t. This one's a product rule. Differentiate the first one, leave the second one alone. Differentiate the second one, leave the first one alone. Right, so that's our derivative. Now, I'm not going to bother simplifying it. It does scrunch up a little bit, but I'm just going to plug in 0. So y prime of 0 equals 2a minus 3b plus 1/5 plus nothing equals 0. Right, so this one goes away because there's a t sitting out the front. Right, and t is 0. So we've got a equals minus b. We plug that in, we get minus 5b equals minus 1/5. B equals 1/25. A equals minus 1/25. So at the end of the day, we should have what did I end up with? Plus 1/5. And that should be our particular solution for this problem.